So I'm just gonna start with the kind of the first part of the code up to the B and A coefficients where I have to draw it out. I'll do that in a separate video, and then I'm gonna do the last part in another video because it's just the software I'm using with Vimeo. I'm only able to record in shorter sessions. So I'll start here. So I have a, let me just clear all, and then I'm gonna clear the window. I made a recording earlier. That's my Spotify. Of here, just me saying my name. Close it down. If it wants to load. Okay, it's not really loading. Don't know. Okay, so first of all, I'm gonna load in that recording that I made earlier, and then I'll you know, get the B&A for plot it, and then get the B&A for the Butterworth filter. So to start, we're just going to load in the file, our input, and our seek2 audio read. I'm lazy. I'm just going to properties, copy and paste that, and then backslash, and Lorcan Mac, and then actually I'll just get this name. Sorry. No, that should be okay. And then we're just gonna sound IP at the 44,100. Don't know if you hear that, but anyway, I played the audio there. Just in case, I'm gonna just quickly do this part. Make it a vector, single vector, and then we're gonna create our time vector for when we plot it against time. We need to create a time vector that is the same length. So we go from 0 to the length of IP minus 1, and then we have to divide that by the frequency divided by fs, and then we plot IP plot t against the IP, and there's the plot there, and then we're just going to y label the axes, y label amplitude, x label, and it's going to be time, and that's in seconds, and then when we open it, we can see our time, and then we can see our amplitude on the y label. After that, we're going to create the random high frequency noise. So it's rand n size, and it's going to create the same size as our initial input of the recording. That's what I meant. And then we are going to create the filter for that. So we're going to say B A is equal to butter. We're going to create a 6th order system. We're going to get, we have to, first of all, sorry, we have to copy and paste this in to know what we are doing it for. So that creates our two noise cut off and our tone frequency. So now we can do our B&A coefficients for that to create the filter, the high frequency filter. Butter, and it's going to be a 6th order as I said. Then it's this 19257 divided by, to normalize the frequency, we have to divide by fs over 2, and then that's created the Butterworth filter. Sorry, and I forgot high. One last thing, and it's high. So now we've created the filter, That should be 2. And I can't spell butter. So then we filter the NS, the random noise, with this. So we say filter using the B&A coefficient just created, NS. And then I'm just going to create the tone, the high frequency tone. I'm going to say 0.2 times cos of 2 times pi times, this is where the tone frequency comes in, 2413, and then times the time vector that we created earlier. With all them made, then we can create our signal. So it's going to be equals the initial input plus the NS plus the tone. And of course, that's the one there. We have to, because it's, yeah, the way it multiplies out, so you have to add in the tick, of course. So then it's the B&A, we create a filter based off this. B&A is equal to butter, and this is going to be the low pass filter. 19257 divided by 2 and divided by fs over 2. So I believe that's this part done. We made that. Plot the speech. That was to create the tone frequency and the noise cutoff. That's the high frequency noise and the tone. That's we created that. And then that's the second order filter. Sorry, that last part was second order filter, and that's half the noise cut off. Back, this is half the. So yeah, this second order and half the noise. And then so I'm just going to draw the filter in a separate video. So I will stop.